Hey, let's look at how to do a few more questions for examples on these Lewis structures. So you've seen some of these in a previous video. Let's look at another one. For example, H3o Plus, and I'll write it out on a bigger piece of paper to make it easier to see. H3o Plus. So let's do step 1, count valence electrons. Hydrogen has 1, oxygen has 6, so that's 3 plus 6. So 3 valence electrons here, 6 valence electrons here, because each one has 3, or each one has 1 electron, so 1 times 3 is 3. And so that's a total of 9 valence electrons. And then because it's got that positive charge, this means subtract an electron. Subtract an electron. So that means 9 electrons minus 1 equals 8 valence electrons. So 8 valence electrons belong in this molecule. So what do? We decide we need to, that step 1 is calculate how many electrons. And this is it. This is how many electrons. Step 2 is put together the molecule. So we're going to put oxygen in the middle, and we'll spread the hydrogens evenly around. It doesn't matter if I put a hydrogen on top or on bottom. It doesn't matter. I just spread the hydrogens around. And then step 3 is make sure you've got 8 electrons. So this is 2 electrons right here because a bond represents 2 electrons. Here's another 2 for 4. Here's another 2 for 6. So 2, 4, 6, and 8. I'll put the 8th set of electrons there. Not here, because if I put electrons on any of these hydrogens, they would have 2 plus 2 more for a total of 4. So I got to put it here. And then I check against the rules. So Octet Rule says if it isn't hydrogen, it should have 8. So oxygen, 2, 4, 6, 8. So that's 8 electrons. The oxygen's good. This hydrogen has 2 electrons, so it satisfies the duet rule. This hydrogen and this hydrogen also satisfy the duet rule because they each have 2 electrons. Therefore, this structure is valid, but remember, it's positively charged, so we got to do one more thing. Brackets and charge. This right here is the final answer that we want. That's your final answer for H3o Plus and its Lewis structure. All right, let's do another one. Nh2 Minus. Again, I'll write that bigger. Okay, nitrogen has 5 valence electrons. If you look at the periodic table, you can tell it has 5. Hydrogen has 1, and there's 2 of them, so 5 plus 2 equals 7. And then this means, this negative charge means add 1 electron. So 7 plus 1 equals 8 valence electrons. So we do as we often do many times, not always, but many times the first letter is the one in the center and the rest are evenly spread around. So we'll put nitrogen in the center and we'll put the hydrogens on the outside. I could put the other one here or here or here. Just for fun, I'll put it here. And then the next thing we got to do is after we build this, we counted the valence electrons as step 1. Step 2, build the structure. Step 3, you need to spread the correct number of electrons out. It says there's supposed to be 8. So 2, 4, and then I can't put any more on the hydrogen because the hydrogen can only have 2 electrons, and this is it. So 2, 4, and I guess I have to put the rest on nitrogen. 6, 8. And then what I do after that is stop because you're not allowed to put more than the right number. So 2, 4, 6, 8 valence electrons. That's good. Grand total. And then we check, does it satisfy the rules? This hydrogen has 2, so that satisfies the duet rule. That's good. This one has 2 and satisfies the octet rule, so that's good. This is going to need 8 valence electrons, like all elements greater than element number 6, which is greater than carbon. So let's see. This nitrogen has 2, 4, 6, 8 valence electrons. So it also passes the octet rule test. So this structure is valid. Last thing, because it is charged, don't forget brackets and charge to get your final answer for that one. So that's another one. Other ones on here are going to follow a similar course. Let's mention one final one. Number 18. So silicon and then 2 chlorines and then 2 bromines. So let's write that nice and big to make it easy to see. You've noticed the pattern with most of these. There's one atom in the middle and the rest are spread around. So we're going to follow that here, but first you need to remember the first step is count valence electrons. So we check the periodic table, and that will tell us how many valence electrons for each one. So silicon, according to the periodic table, has 4 valence electrons. Chlorine has 7, and so does bromine. So this means 4 plus, see, 2 times 7 is 14, plus 2 times 7 is 14. So 14 plus 14 is 28. This is 32. So 32 valence electrons. So given that reality, here's what you got to do. That's step 1, count how many valence electrons. Step 2, build the structure. So we're going to put this in the middle and spread these evenly around. So let's put silicon in the middle, and then we'll spread the chlorine out. It doesn't really what order you put them on, the chlorines and the bromines. You could have put a bromine down here or up here, or you could have like 2 bromines, 2 chlorines, or 2 bromines, 2 chlorines, whatever. It doesn't matter. Either way, you just get them on there with the silicon in the middle, and then what you got to do is make sure there's 32 valence electrons on here, because step 1, count the valence electrons. Step 2, assemble the molecule. Step 3 is put the valence electrons on. So 2, 4, 6, 8 so far. And let's spread the rest of them around. And start on the outside atoms first for these larger complex ones, and then go to the center if you have to. But let's see. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We stop at 32 because I said we're supposed to have 32. So let's look. I put on 32. Did that work? Well, this bromine, we got to check against the rules now. There's no hydrogen, so these all have to satisfy the octet rule. Bromine has 2, 4, 6, and 8, so bromine is good. Chlorine has 2, 4, 6, and 8, so chlorine is good. Bromine has 2, 4, 6, and 8, so bromine is good. Chlorine has 2, 4, 6, and 8, so chlorine is good. And silicon has 2, 4, 6, and 8. Therefore, it's good, and this satisfies all the rules, so it is good. Finally, notice there is no charge on the molecule, so do not put brackets and charge here because it is not a charged molecule. That's it. This is the answer right here. I suppose maybe one could put a box just to emphasize that it's the answer, but nonetheless it is. This is the final answer right here, and that gives you an idea of some more examples of how we handle these sorts of structures.